Hello. You're going to use this video to reflect on your October mock exam and mark your own work, make notes on how you could improve. So these are the worksheets that have been handed out. Just to take you through some of the key points. One of the questions in the mock was giving disadvantages of natural timbers. The answers are that natural boards are more prone to movement. They're more likely to twist or warp, so they're not as stable as manufactured boards. That's one thing that can happen. They also have defects like knots, which are hard and can cause weaknesses in the timber. There's a knot, it's where a branch grew out of a tree. You're not going to get that with a manufactured board. And finally, you could also say that you're restricted to certain stock form sizes like planks. You can't get big sheets like you can in manufactured boards. So they're big sheets, they're flat and stable. Okay, the next question, one of them was on calculating the path that a laser cutter has to follow. Many of you actually calculated the area incorrectly or parts of an area. What you should do is remember that um, uh, you need to calculate the straight lengths first of all, which is 5, 8, and 5, and then you needed the distance of half a circle circumference. So that's the actual answer in the exam. That's what you should have got. Here's a follow-up question for you to attempt. It's a similar thing. You have to first add up all the straight lengths, which would be 26 and 18 for the bottom and the right. And then on the top, you have to look at the length and then subtract 8 millimeters because that's the actual radius there. So on the left, it would be 18 up and down minus the 8. That gives you one straight section. The top would be 26 across there. Again, minus 8 for that radius there. And if you add them up, all the straight sections would be 72. And then what you need is a quarter of a circumference of that circle. 2 pi r is circumference, so just needed a quarter of that. If you plug the numbers in, you end up with a total length of 84.56 millimeters. Okay, one of the questions was on a material reinforcement. Now, there's what that means is basically layering, forming, folding, or manufacturing materials in a particular shape to improve its strength or rigidity. That's the actual definition of reinforcement. And there are some examples there, like ribs in plastic where it's been injection molded. It could be interlacing, like weaving a fabric. It could be structural shapes like I-beams or folds as well in corrugated card. So they would be some examples you'd need to name. Okay, product analysis. This is a really important one. You're always going to get questions like this. One of the things that you could have mentioned is think about the actual user experience on that product. So I'd be saying things like the polymer covering is easy to wipe clean if you're sweaty. It can be adjusted for different exercises. So think about the kind of activities someone would do. Someone would want to do inclined bench presses, for example. A negative, that bolts they can actually shake loose, and that could be a safety hazard. Recessed fittings, by the way, they look something like that. They've got basically flush ends so that you're never going to snag on them. That could be a positive. So many of you didn't consider enough of the specification points, and you need to have strengths and weaknesses. Consider what it would be like to be on that equipment. When it came to anthropometrics, many of you did a pretty good job of saying how it caters for the majority of people, but actually for the marks, you really need to refer to the data itself. So make it really explicit the numbers you're talking about. So some general points of that equipment could typically be designed to the measurements of the 50th percentile to make it comfortable for the majority of users, but you should accommodate up to the 95th, the biggest people in society, and down to the 5th percent. That's to maximize inclusivity. And an example would be, for example, the rest where the weights are shouldn't be more than 390 millimeters from the actual bench. That's, if we look at the numbers, the length of arms for the 5th percentile is 390 millimeters. So you want to be able to accommodate down to that size person. That means the smallest person could safely lift the weight off the bar. Just look at the data and use some of that information yourself. So you're going to have a follow-up question like this, and you're going to analyze and evaluate the playground for its suitability for children, and then inclusion of safety features, and then look at the anthropometric data of children there of different ages and say how you'd use that information. Now, if we look at the mark scheme, for 3 to 4 marks, you need a well-described and justified analysis containing full evaluation, drawing conclusions, having considered a range of factors. So that's what you need to do. And here are some indicative points for suitability of your user. For example, bright colours are engaging to children. The house feature may promote children interaction. lots of different things for them to do. It's kind of stating the obvious, it's stating what you see, isn't it? And then for the inclusion of safety features, it's basically justifying a lot of the specification points. So no slip surfaces will help prevent a fall. Use of anti-tamper fittings reduce the risk of malicious tampering or vandalism. Anyway, there's the mark scheme for that. For the anthropometrics, again, for the 3 to 4 marks, you need a well described and justified analysis of the data containing a full evaluation. So here you see the first point. Designer would ensure that the equipment is designed to an appropriate size for the intended user, e.g. hands 55 to 65 millimeters wide. So there you go. They've looked at the smallest hand size for someone who's 4 and up to 12, and they would make the handlebars that sort of diameter. Okay, so again, pause it here and look at the mark scheme if you need. And then finally, I've just put a little orthographic and to isometric drawing task. So this is how it should have looked in the exam. And for the follow-on task I'm giving you, it would look something like that. Okay, so best of luck, mark your work. Please go back and rewatch these sections if you need.